Okay. We are going to add and subtract radical expressions. So I think the more you get used to the vocabulary of this unit, the easier it is. So as we, get used to saying radical instead of square root, or we get used to saying your factors, right? It's going to be easier the more we practice it. Hold on, phone's right here. Allie, remember at 1 o'clock. Okay, so, like radicals. Big old pause in the video. Like radicals are very similar to like terms. If you think of them like radicals, if you think of like radicals as like terms, you're going to be good. Like radicals are very similar to like terms. They're radical, and remember the radical is just this symbol, expressions with the same radicand. Like radicals are very similar to like terms. They're radical expressions, so they're problems, with the same radicand. What's a radicand? Who can tell me? Raise your hand. What does radicand? Where is the radicand
In the radical.
located? Where is the radicand? How am I going to know if they are like radicals? Allie, where is it? Inside the radical. So let's give a few examples. 2 radical 5 and negative 8 radical 5. Those are like radicals because they have the same radicand. Their radicand is 5. They're like radicals. Negative 6 radical x and 1/2 radical x. Those are like radicals because they have the same radicand. The radicand is x. The radicand is x. They're like radicals. Non-examples. Some people would say 2 radical 8 and 8 radical 2. Can you see that? They don't have the same radicand. What's the first radicand? 8. What's the second radicand? 2. They're not the same. 6 radical x and radical 6x. They are not like radicals. Why not? Well, this radicand is x, and the second radicand is 6x. They're different. They have to be exactly the same. And if you have like radicals, you can combine them. You can use your order of operations. So, if the radicands match, there's a C in there, M-A-T-C-H, add or subtract the coefficients. It's just like terms. Can you add 3x and 4x? Yes, they have the exact same variable. Can you add 12y and 14y squared? No, because they don't have exactly the same variable. If the radicands match, if they're exactly the same, if the radicands are exactly the same, terms, you add or subtract the coefficients. You want to try some?
No.
They're pretty easy.
No. Goes against my religion.
3 radical 7 plus 8 radical 7. Do those radicands match?
Yes.
What's the first radicand? 7. What's the second radicand? So they match. They're like radicals, like terms. So 3 radical 7 plus 8 radical 7 is 11 radical 7. And you're done. If the radicands match, add or subtract the coefficients. 3 plus 8, because they have the same radicand. 9 radical y minus radical y. Do they have the same radicand? Yeah, radical y, they're the same. What should I add to this problem?
A 1.
A 1, a coefficient of 1. So what's the solution? 8 radical y. Seem pretty easy?
Yeah.
All right, so let's try this one. Radical 7 minus 4 radical 11. Why can't you do it?
Error 404 non-system.
Why? They're radicand. 7
Radicants.
and 11. Very punny, Alex. Alex says they're radicants, not radicands, right? They don't match. So that's just your solution. Sometimes that happens.
Will we learn how to solve them in the future?
Right now. Type 2, problem type number 2. Sometimes, 50% of the time, 75% of the time, you need to simplify the radical first. Sometimes they're not that easy. You can't just look at them and do it. Sometimes you need to simplify the radical first. All right, here we go. 3 radical 8 plus radical 45.
Guess time.
Now, before you start automatically going into the factor tree, which works, if factor tree is what works for you, 100% hands down do it. Or you can get really good at factor squares at your factory. Now let's talk through factor tree first. What times what is 8?
4, 2.
4 and 2.
4 is
2 is prime. What times what is 4?
2 and 2.
2 and 2. Those are prime. So we're done. Now let's move on to 45. What times what is 45? 5 and 9. And 5 is prime. What times what is 9? 3 and 3. Then we go through and we look for our pairs, correct? We've got a pair of 2's. So my answer up here, I'm going to still have that 3, which is my coefficient, times I had a pair of 2's, so 2. And what's left over? Radical 2. If I look at the next one, do I have any pairs? 3 and 3, so I bring that out. And what's left over? 5. That stays inside my radical. Simplify the beginning. 3 times 2 is?
6.
6 radical 2 plus 3 radical 5. Can that be combined? So that's my solution. Arlo, what was your question? Yes, multiply your coefficients out front. Factor tree works every single time, but I don't think you need the factor tree if you get really good at your factors. For example, radical 12 plus radical 27. I go straight to factors. What times what equals 12?
6 and 2.
Okay, 6 and 2, but neither of those are perfect squares, are they? Is there any way to get to 12? 2 times 6, no. 3 times 4, is one of those perfect? Yeah. So you don't need to do the factor tree all the time. Are there circumstances where you need to? 100% yes. Plus, what about radical 27? What times what equals 27?
3 and 9.
So we look at 27, 3 times 9, and is one of those perfect?
Yeah.
3 times 9. All right, I can't do radical 3, but I sure can do radical 2. What's the square root of 2? Or the square root of 4?
2.
So bring out your 2 and leave your radical 3. Plus, can you do radical 3? But can you do radical 9? What's radical 9?
3.
Take out a 3 and leave what? The 3. 2 radical 3 plus 3 radical 3. 5 radical 3. Let's try another one. 5 radical 28x minus 8 radical 7x. All right, so let's talk it through. 5 is my coefficient. It stays. How do you make 28x? 7 and 4. And is one of those perfect? 7 times 4 times x, right? Equals 28x. Minus 8 is my coefficient. It stays. And can you break down 7x? 7x. All right, looking at this problem, what can I pull out of the problem because it's perfect? What is the square root of 4? 5 times 2. And what's left inside the radical? What's the radicand? 7x minus 8 radical 7x, because this one cannot simplify. Can you do more simplifying? 5 times 2 is 10 radical 7x minus 8 radical 7x. And you can still combine like radicals. 2 radical 7x. Let's try one that looks scary but isn't scary. Radical 125b plus 3 radical 20b minus 45 radical b. Do you know factors of 125? It should be something that you become familiar with.
5.
5 and 25. 5 times 25 times b. Jimmy, you need to be taking notes. Plus 3. What about 20? B. Are 10 and 2 perfect? 5 and 4. 5 times 4 times b. Minus 45. Can you do anything to that radical b? No. All right, let's talk about what can be taken out. What are perfect squares? 25. What's the square root? What's radical 25? 5. What stays inside the radical? 5 and b. Plus, what about the next one? What comes out? 4. What's radical 4? 3 times 2. What stays under? 5b. Minus 45 radical b. Is that my answer? What should I do now? 5 radical 5b plus 6 radical 5b. 3 times 2 is 6. Minus 45 radical b. Is that my answer? Now what do I do? 5 radical 5b plus 6 radical 5b is 11 radical 5b minus 45 radical b. Why can't those go together? What's not the same? The radicand is not the same. It's just like terms, you guys. Except with the added twist of pulling out perfect squares. All right, last one. One more with more variables. Okay, radical 48x to the third plus radical 12x to the seventh. I'm going to show you a trick with exponents. 48 x to the third, radical that, plus 12 x to the seventh. Jimmy, again, we're taking notes. All right, what times what equals 48? 8 and 6. Are either of those perfect? Nope. Look at your paper.
6 and 8.
6 and 8 are not perfect. 4 and 12 work. Is that the biggest combo? Look at 48.
24 and 2.
Is 24 perfect?
Oh, wait, no, wrong.
16 and 3. 16 times 3. How do you make x to the third? You could put 3 of them right there, right? X times x times x. Now let's move over to radical 12 x to the seventh. How do you make 12?
4 and 3.
Could you do 2 and 6?
No.
Why not no?
Because 6 is perfect.
6 and 2 aren't perfect, but 3 and 4 are. One of them's perfect. Could you do the factor tree like this problem if you don't get it? Yes. X to the 7th, what could you write for that?
7x.
You could put 7x's, or I'm going to put this. How come I'm going to put x to the 6th and x to the 1st? One, it saves space, but how come I can do that? Yeah, if I break it into an even, it becomes perfect. So I take 7 and I make it 6 and I add the extra 1 to get to 7 off to the side. So let's go. Square root of 16 is 4. Anything else perfect underneath this green radical?
On the x side.
I can pull out 1x because that's x squared. And what's left behind? 3x. We're almost done. Looking over here, what can come out from underneath? 4. Radical 4 becomes 2. What else can come out? X to the 6th. Radical x to the 6th becomes x to the 3rd. And what's left inside? 3x. And you guys, we're done then. Because you can't combine the outsides because they are not like terms. My radicands are the same, but my coefficients are not like terms.